Hi, first of all, if you go to the course website over there, so just show you the things you should really pay attention to. First of all, for lab test number 4, it will be next Tuesday and Thursday. So there's a preparation guide over there. You can read it over. Basically, only recursion will be covered in the test. Simply linked list, stack, queues, anything else is not covered. Just review the recursion, okay? But look at the guide, okay? It's detailed over there. And then I uploaded some new stuff over there for the inheritance. So there will be some additional readings for you to read, to do in order to understand inheritance more. But we'll talk about it today. And hopefully the reading will make more sense once we go over the key critical points. Okay, first of all, I would like to just talk very briefly about the protected modifier. So I received a couple of emails over the weekend with the concern that what if you got private attributes in your superclass? Will they be inherited to the subclass? The answer is no. But let's understand the complete story before, and then I'll do a full comparison of all the modifiers. So remember, if you can go back to the lecture for utility classes, we talk about either you got public or you got private, we have no modifier, in which case it's package level visibility. Now we introduce the last one, which is called protected, okay? Let's just review what we had before, and then let's see why the protected could be useful at some point. First of all, we know that private attributes are only restricted to the current class, excluding subclasses even, okay? And then we also got, if you have no modifier, that means anything inside the current package can get access to it. And also, you got public, in which case you got project level visibility. Any class within the package, within the project across the packages, they can get access to it. Okay, you can refer to the lecture from before. Now, let's say we want to have a new visibility, which is not really supported currently. Let's say we want attributes to be, somehow they're visible to be, let me give you one example. Okay. Imagine that, you can also see the code example from the website. Let me just show you that. Okay, let me just go over this example directly, okay? Remember what we had before, we got collection of stuff projects. We got animal, we got furniture, and we got shape. For some reason, for the class called chair, let's say we want to have two subclasses, two. One is called bubble chair, okay? Just one kind of chair. The other is called rocking chair. But for some reason, we want to put these two subclasses in different packages for some reason, okay? So now let's say we got bubble chair, we got rocking chair. Now we want to make the attributes in the superclass, which is chair, we want to make the attributes and methods to be available to all the subclasses, either in the same package or in the different package. How can we do that? The answer is you do something called protected. So what's the difference between protected and package level visibility? Here's the difference. If you simply take out the protected over here, which means no modifier, in which case the visibility is only restricted to the current package only. But now if you add protected, it's going to extend the visibility to any other subclasses for the current class. Okay, that's the difference. So if I go back to the original one, so now somehow you want to make it visible to all the subclasses outside the current package. And also you want to make sure it's invisible for any non-subclasses in other packages, right? For example, you can see over here. Now, let's say you can see the only subclasses for chair would be bubble chair, which is in the same package, and also rocking chair. Rocking chair is in a different package, but it's a subclass, so it should be also visible to it. But I can see circle and square. They are not subclasses of the chair, so that's why they cannot see it, because it's protected. Okay, so that's the new modifier you can feel free to use. Okay, now, before I make some assumption for the rest of the lecture, let's just go over all the modifiers we have talked about. So let's start with the most relaxing, the least restrictive modifier. First of all, we got public, okay? Whenever you declare any attributes or methods as public, what does that mean? That means any class, any package, and any package within the project can access to it, so all green bar. It's just visible everywhere. That's the simplest case, but you gotta be careful. Sometimes you might want to put some restriction on your attributes or methods. The next one would be protected. So protected basically says that we are going to make the attributes that's declared as protected to be visible to the current class, to the same package, including the subclasses in the same package. And also for the subclasses that's not in the same package as well. But for any other thing in the project, it's not visible. Okay? You should really download the source code and see. Okay, I did create an example for you to try. The third one is, let's say we simply got the old modifier, which means no modifier. In which case, you can only get access to the classes within the same package. Anything that's outside the same package is not visible. Okay, that's why you got the 2 red over here. Finally, we got private, in which case the private one is only visible within the current class. Outside the class in the same package, or outside the class in another package across the packages is also not visible. Okay? Any questions about these 4 modifiers? Okay? It's something you should know, but it's not really that important for the concept. Okay? Good. So now, let's make some assumption over here. So for simplicity, for the rest of the discussion for this lecture here, anytime when I declare any attributes in the superclass, I'm going to make it at the package level, which means I assume all the relevant descendant classes will be in the same package. Okay? So there's no these subclasses that will be outside the current package. I just want it for simplicity. Okay? Okay, so you will see that for all the attributes, I simply have no modifier. If I say private, that means they are not inherited. If I say no modifier, they are inherited to all the attributes, to all the classes in the same package. Okay? Any questions about the modifier? Okay, just protect it. Okay, let's now review very quickly what we said last time. I'm going to recap very quickly what we have got. So now what we got from last time, we got a very simple inheritance hierarchy there. So you can see that at the top, we have a common superclass called students. And then we got 2 subclasses. It can be either resident students or non-resident students. In the superclass, we try to declare all the common attributes and methods. So we have name, we have registered courses, we also got number of courses. Okay, we also got the register method as well. Okay, and also we got some part that will be reused, get tuition. Okay, in the subclasses, typically you can either add new or new attributes or new methods, or you can try to redefine the methods or attributes. Well, sorry, just methods. You can redefine the methods that you inherit from your superclass. Okay, for example, over here, you can see that. Let me just use a different color here. You can see that first of all, you can see that the premium rate over here is a resident student specific attributes, and also set premium rates. So these are unique to this class over here. And also you can see discount rate is only unique to the non-resident students, and also set discount rate. Okay. One more thing to note, you can see also that over here, for the get tuition over here, is inherited to this resident student, but we try to redefine that. Okay, the method is still there, but just redefine. Similarly, for the get tuition in the non-resident student, we redefine that so that you will calculate based on the discount rate. Okay. Now, given this inheritance hierarchy there, so what we said last time was, we talked about something called expectation. Okay, that's something you should really review. Expectation. Okay, what does expectation means? First of all, you can see that we are trying to declare this variable over here as RS and NRS. So these are declarations, and then the type we declare S to be is called students, and also resident students and non-resident students. When we declare a variable, it's called static type. Okay, static type. As soon as the static type is declared, it's going to tell you what expectation you might have for that particular variable. For example, you can see for S over here, you can call any attributes or methods that are actually defined in the static type of S. In this case, you got name, register courses, number of courses, register, and get tuition. But you cannot call any of the subclasses attributes or methods. You cannot do that. Because student over here is actually the one at the top. It simply doesn't know about anything that's specific to the subclasses. Okay? And similarly for RS and NRS. Okay? So far, just a recap from last week, just to make sure we are ready to have further discussion. Any questions before I move on? Okay, very good. Now, let me just, there's another hierarchy I want to mention very quickly, okay? You know what, let me go back to this hierarchy here after the questions, okay? I'll come back here. So this is just another inheritance hierarchy we are gonna use for the rest of the lecture. But now I want to go to some intuition for polymorphism first, okay? Now, alongside with this, I'm going to draw some diagram. Okay, now let's try to go over some code, and I'll ask you questions. First of all, let's say we are creating a student object, Stella, okay? Let me just go back to my iPad over here. So we're basically saying S is going to point to a student objects. Okay, and then over there we have name, and then there should be Stella. And there should be other attributes over here. I'll leave them just implicit for now, so for you to think about, okay? Let's see the next line. The next line over there, we got another object there, RS, of type resident students, Rachel, okay? Also, we got RS over here, that's just pointing to another object over here, and then it's resident student, I would say RS for short. And then the name over there is Rachel. Okay, you also got other attributes for RS, okay? Now, let me ask you two different questions, okay? I'm gonna just write it here directly. Let me say this, let's say number one, if I say S is assigned to RS, number two, RS is assigned to S, number one, number two. Which one will compile and which one will not, or both? Okay, first of all, just give me a number. Which one will compile? First one will compile, so why not the second one? Can you explain? Okay, you guys are pretty good because that's the correct answer. Okay, because number one will compile, but number two will not. Okay, that's the answer. First of all, let's see in Eclipse, and then I will show you how uninformative it is in Eclipse. Right? So now, so the answer is, first of all, and then the justification is actually more important. The answer itself is not that important, I would say. First of all, we know that this will compile, but this will not. Okay, let's keep that in mind. So now let's go to Eclipse, and then I simply just reproduce the assignment over there. You can see student S, resident student RS. I say S is assigned to RS, there's no red underline. That means it compiles. And then when I say RS is assigned to S, it actually shows an underline over here in red. Okay, let's try to read it. If you move your mouse over that, let's see what it says. It says, type mismatch cannot convert from students to cannot convert from student to resident students. Okay, well, in some way that's true. You cannot convert from student to resident student, but why not, right? Anybody want to try to explain why number two would not compile? Why? Okay, the answer was, what you just said was, we can see students, we can see resident student as a kind of students, but we cannot see a students as a kind of resident students. That's not really explaining. Not really. Well, you're on the right track, but it's not really explaining too much. Not too much. Go ahead.
I'm assuming that because resident student might contain some field that's required, whereas in this case, student does not.
Aha, okay, very good. That's exactly correct, okay? So now, let me just try to hide the answer a little bit, okay? And then I'm gonna present it in a slightly different way, okay? So guys, let's try the following. Number two, how do we somehow prove that it does not compile? Why don't we prove by contradiction? So proof by contradiction, as you learned from the previous math course, if you want to prove that something is actually not correct, why don't you just assume it is correct first? And then it will lead to some contradiction. Contradiction in the programming sense, crash. And then in that case, we'll see our original assumption was actually wrong. Okay, let me show you, okay? It's actually not too difficult to understand, but the main thing is you should really understand what do I mean by expectation. It's really important. It all comes from there. Okay, let's try to prove by contradiction. Okay, I would say over here, so proof by contradiction. Okay, for number 2. Let's say we assume RS is assigned to S compiled. Let's just assume that. And then I'm going to show you that if we allow this to compile, we're going to lead to some contradiction at the runtime, which means crash. If that's the case, that means our original assumption was simply not right. So that means it should compile. It should not compile. Okay, that's step number 1. So now let's say this. If this compiled, at the runtime, what does that mean? When I say RS is assigned to S, I'm trying to do some kind of like a substitution. What do I mean? So now, how should I change the arrow if I say RS is assigned to S? Should I say S is now pointing to here or the other way? Okay, give you 2 choices. Choice number 1. So what does it really mean? When I say RS is assigned to S, what does it really mean, graphically speaking? Number 1, I change the arrow from here to here. Or I do the arrow from here, change to there. Number 2, right? Number 2 or number 1? Okay, again. Okay, let me just do it again. Okay, number 1, like this. This is number 1. This is number 1. Okay? What about number 2? Number 2 is this. Number 1, number 2. Number 2, right? Okay, please, it's very important. So number 1 means we're going to copy the address that's stored in S and copy that into RS. So that means RS is now going to point to wherever S is pointing to. Okay? Now, let's say we do that because we allow that to compile, so that should be executed. Now, step number 2. What's the expectation? Expectation for RS. You can see RS over here is declared to be, if you look at there, RS was declared to be a resident student. Agree? Okay? That means, what is the expectation for that? Resident students. Well, for that, you can see that, let's just go back to the diagram here. For resident students, what can we expect from that? We can expect premium rates, we can expect name, number of courses, and also the registered courses, right? So you can see for RS over here, these are all the expectation for the resident students. One of them is simply just premium rate. Okay? So now, what does that mean? That means, let me go back there. That means at the runtime, we can call rs.premium rates. Okay? Simply, you can see that again from the previous table over there. We can simply say rs is okay. Sorry. So now from the previous table, it's exactly this entry over here, right? Because we can call that. Okay. So now, what's going to be the problem here? If I say rs the premium rates. When I say rs the premium rates, I'm talking about I want to get the premium rates for this student objects there. The student object have a premium rates? No, right? No, because student object, as we said last time. Let me also talk. Let me show you very quickly again. If you go to the slides for visualizing the parent and child objects, okay, let's see where. I think visualizing over here. Okay, over here. Okay, you can see that the previous slide in the student class, for any student object, we only got name, number of courses, and registered courses. Okay, but for resident student, we also got premium rates. But now, since we allow that line to compile, which means it's going to allow this thing over here to happen. Okay, right? This thing over here. And now when we say rs.premium rates, it's simply not there. So that means it's going to crash because it's simply undefined. Okay, that means it's going to be crash because undefined on undefined on student objects. Okay, that's proof by contradiction. Which means, how do we prove that line number 2 shouldn't compile? We just assume it would compile. And then we're gonna have the assignment like that. And then whenever you call rs.premium rates, it's gonna crash the program. In which case, that's not good. So that's why the Java compiler would have disallowed you to do this at the compile time. So you wouldn't have any such issue at the runtime. Okay. Guys, any question about this? That one is just supposed to give you some intuition about why one way will work, but not the other way. Raymond, are you okay?
Yeah, so how would you set, let's say a student no longer a resident?
If a student is no longer a resident, what do you mean?
Let's say
Uh-huh.
non-resident student.
Oh, okay. So now you can see, first of all, I'll take your question in a moment, okay? Now we know that, first of all, line number 1 is okay. So now, that will be actually dynamic binding. We'll get there in the next slide. But just as a look ahead, so now S is assigned to RS is okay, right? Because the only expectation we have on S would be just the name, number of courses, and registered courses. Those attributes are all inherited to the resident student objects. So that's okay. So now, let's say we want to change from resident student into non-resident students. What you can do is, in another line, maybe S is assigned to NRS, in which case NRS is just another object. Okay, I'll get there in just the next slides. Yes? Sorry, say it again? It's a very good question. That's also dynamic binding. I'll also get to that in the next slides. For example, in this case, let's say the get tuition method, right? Depending on if that happens to be a resident student, you apply the premium rates. If that happens to be a non-resident student, you apply the discount rate. Depends. Okay? But first of all, let's get it straight. Anybody have any question about why line number 1 should compile, but line number 2 should not compile? It's really important. Okay? If any questions, just ask.
So, in this case, we apply reference student to reference of this student.
Mm-hmm.
So, if you try to call a method that is just for reference student by using that,
Mm-hmm.
that works.
Okay, the question was, you're talking about line number 1, right? You know what? I will get there maybe in the later slide. It will be a little bit too much at one go. Okay, yeah. Okay, let's go to the next one. Okay, if no questions there. Okay, again, I got some additional readings for you on the website. You should really try to read it. Okay, the intuition. It's really important to get it. Okay, let's now go to. Okay, so now if you go to the slides, so that's exactly how I actually said the things. You can just go over why. One is valid, the other one is invalid. Okay, that's something I'll leave to you. Now, let's talk about, so that's about polymorphism, which means you can assign some descendant classes objects into superclass type, but not the other way around. Okay, that's basically what polymorphism is about. Okay, so now, let's talk about another concept before we move on to more formal rules. Dynamic binding. Dynamic binding simply means I might change the student type from resident students into non-resident students. In both cases, if I try to call get tuition method, the different version should be called because the get tuition method is overridden in both subclasses in a different way. Okay, let me show you an example here. Let's say over here, let's say we got, again, 2030 over here, a new course, $100. And then let's say we got line number 2. We simply declare the static type of S to be students, just that. And then in line number 3, we simply say that, we also say resident students RS is a new resident student objects, okay? And then line number 4, we just got another NRS, non-resident students objects, okay? So we got 2 objects of different types, 3 and 4. Now, and we also say RS dot set premium rate to be 1.25, and then register 2030, okay? And then we also try to set a discount rate for NRS, and then 0.75, and then 2030, okay? Now let's try that. If I say S is assigned to RS, as we learned from the previous slide, this assignment here should be allowed, right? So now, if I say S is assigned to RS, so now that means it is now pointing to a resident student objects, right? Because we know that RS is pointing to a resident student objects, right? I'm going to show you a diagram in just a moment. And then, now, if I say S.getTuition, what should that be? Should I get 100 or should I get something else? I heard 125. Okay, anyone else? Okay, why don't we try? Okay, now let's try the following. Now let me just go back a little bit. Let's try this. Okay, let's try this. Let's say first of all we say student S. So we have students S over here. It's going to be a pointer. And then what we have is another one. Let's say we got resident student RS. Okay, so we have resident students RS. So now RS is pointing to a resident students objects. I'll say RS, resident students object over here. And, sorry, wrong way. And we got Rachel over here. And also we got NRS, Nancy. Okay, over here we got name over here to be Rachel. And then we also got NRS that's pointing to a different kind of objects. In this case, NRS, non-resident students. Okay, the name over here is Nancy. Okay, let's go on with the code. And then what we have is we say RS the set premium rates 1.25. Okay, and then we also say RS the set discount rate 0.75. Okay, let's see what that means. Okay, so here we say we got RS, which has the premium rates, and 1.25. And then for the NRS, we set the discount rate over here to be 0.75. Right? And for both students, we register them. You know what? Maybe I just close this, otherwise. I always forget. Okay. Okay, so now, and then we'll say that we'll register them for both to be 2030. Okay, let's assume that it has occurred. Okay, now, when we say S is assigned to RS, what does that mean for the diagram? If I say S is assigned to RS, S is assigned to RS, that's what it means. So now, when I say S.get tuition, S.get tuition over here, because S is now pointing to a resident student's object, which has only the premium rates defined, in which case it is registered for the EECS2030, in which case we're going to calculate tuition based on 1.25. In that case, we get 125 for the tuition. Follow so far? Okay. And then let's go through the next line. Now, we say that we reassign the variable. We say now S is going to point to NRS. So what does that mean? That means over here, we're going to reassign S to be NRS over here. Now you can see that when I try to make the same method call to say S.tuition again, now which version is it going to call? Apparently, you can see the diagram over here. When I say S.tuition now, it's going to apply the one with discount rate over here, because it's now I'm talking about non-resident students. Okay, that's why you will simply see that simply will be just 75. Okay, apply the discount rate over here. Okay. Okay, now one more thing to show you. Okay, you can see that over here in line number 7 and 8, we are trying to call the same method called get tuition over here, the same method, but depending on what S is pointing to, it might be pointing to resident students, in which case we apply the premium rates. Or it might be pointing to a non-resident student, in which case we apply the discount rate. Depends. Okay? Now let me just show you one more thing. Okay? So now you can see that over here, when we change from resident students into non-resident students, is a preview for the next slides. So over here we say that this is so-called the dynamic type. Dynamic type over here, and this is just another dynamic type. So when S used to be pointing to RS objects over here, the dynamic type is simply just resident students, in which case calling S.get tuition will apply premium rates. After we say S is assigned to NRS, we simply redirect the arrow into another object over here, in which case we change the dynamic type from resident students into non-resident students. Now, calling the same method s.getTuition, he's going to apply whatever is applicable of the current object that's being pointed to. In this case, it will be non-resident students, and then apply the discount rate. That's why you will have a different answer. Okay? Any question about this fragment of code here? And that one really shows you the essence for dynamic binding. Yes?
So when you assign S is equal to R,
Yeah.
so can you now call S.PMRate?
No, you cannot. Okay. Again, okay. Okay, actually that was asked also by somebody. Let me answer that right away. So here's the question. Let me just create, I know exactly what you're asking about. Let me just create a new slide over here. Okay, the question was, again, let me say students over here, S is new students. And then let me say resident students, RS is assigned to new resident students over here. Okay? Now, if I say S is assigned to RS, I know that S is now pointing to a resident student object. Your question was, could I not say something like S dot premium rates? First of all, can we do that or not? I heard sure. Okay. You don't see why not. Okay.
S is supposed to be of type student.
And please, yes.
Premium rate.
Exactly. That's exactly correct. Okay. So this line over here simply would not compile. No. Actually, I already shut Eclipse down, so you can try that. Okay. So now this one would not compile. Why? Be careful. Again, it all goes back to the expectation. When we declare S is of static type students, so that means anything they can call on S will be defined by this particular static type. What's the expectation for students? Does it include premium rates? No, it does not. So that's why this line does not compile, even if S is now pointing to a resident student objects.
So where is this premium rate now? So where is this premium rate now? Like, you can still like.
You just, I see what you mean. Where is that premium rate? Okay. Now you can see the situation right now is S is now pointing to some resident students object over here, right? And there might be of course, there's some premium rate over here. However, because S was declared as a student object, you simply cannot say S.premium rates. If you simply just have S like this, you cannot do that. Again, it all goes back to expectation. However, if you really want to do it, you can do a cast. That's something we'll get into. Yes, question, and then I'll make some remark.
So calling it tuition because student already has get tuition class.
Correct.
That's it.
Yes,
But it's overridden in the other, right? That's why you
correct. That's correct. That's dynamic binding. Correct. Yes.
So the relationship between the class object and any class we make is
Any class we make, yeah, exactly.
and subclass.
Uh-huh.
And when we are overriding the equals method and actual, it's like doing that.
Get tuition method overriding, yes. Okay, the question was, so now just drawing some connection here. So the common superclass in Java is called objects, and the object class got equals and toString. So they automatically inherit to every class that we define. Okay? If we do not override these two methods, we'll simply call the default version that's inherited. If we do override them, then we will call the redefined version. Okay, guys. Now let me just I'll come back to this point again. It's actually a very common mistake. So over here, I would say this one does not compile because the static type of S, which is students, does not declare premium rates. So here is another principle I would like you to remember. Okay? Every time if I ask you about whether a line compiles or not, you only look at the static type. You don't look at the dynamic type. So here the confusion might come from the fact that you thought, because S is now pointing to some resident student objects, because you thought the premium rate should be able to call. No, that's not right, because S was declared as a student. That type is already there, unless you do some cast. But we'll get to cast in just a moment. Okay? Okay, that was good. Guys, any questions before I move on? Okay? We'll try to repeat a different concept for a number of times from different angles. Hopefully you will get better. Yes? That's a good question. Yes, the question was, yeah. Okay, let me just, as far as, okay, the question was, let's say immediately after this line over here, with a student S is assigned to new student over here, and now if we simply say S dot get tuition over here, what will happen? In this case, because S is now going to point to just a student object over here, student objects, and the student object also got one version of the get tuition defined without the premium rates and without the discount rate. Yes, you will call that version, yes. So now, which version of the method to be called depends on the dynamic type, depends on what's the type of objects you're pointing to. Okay, that's dynamic binding. Yes?
Does dynamic binding need the override notation?
Does the dynamic binding?
Yeah, need the override notation?
Not dynamic binding, no, you don't really need that. Remember when we redefined the get tuition method in the resident student class, we didn't write override. I think Eclipse just wrote it for you, just for indication that you're doing that. Right? Mm-hmm. Okay, guys, you can keep asking questions, that's fine. But let me just go on a little bit. Hopefully that will strengthen your understanding. We got to repeat these points for many times. Okay, you can also go over these. So you can see that's exactly the diagram I was talking about. I'll leave them to you. So depending on which object it is pointing to, it's going to call the corresponding version. So that's dynamic binding. Okay, I'll leave that to you. Okay, let's now go over a little bit formal rules, which you have to know, okay? And then let's see what we can do. First of all, what's a type? A type is simply just a set of related runtime values, like an integer, string, or Boolean. Okay, so they're just different sets of runtime values. And now every class can also be used as a type. So this might be new to you, okay? So every class that you define, for example, person or students or resident students, they also declare, also denotes a type, which means a set of runtime objects or addresses, okay? So now, whenever you got inheritance relationship, for example, the one for students, right? So you have some hierarchy over here. You got students, you got resident student, you also got non-resident student. So that's a type hierarchy, inheritance, okay? Whenever you got inheritance over there, so what do you have? Implicitly, every class is a subclass or descendant class of the object class, implicitly. You don't have to say resident students extends objects. You don't have to say that, just implicitly that happens, okay? Okay, so now, every time when you say extends, that means some upward arrow over there, right? So now, so over here, let me just show you what I really mean by this, okay? Let me just give you one simple example. So now let's say over here, if I have class A, class B, and then class C. Now if I say B extends A, and then I say C extends B, right? Implicitly, I also mean C implicitly extends A. So now that should not, it's something called the transitivity property. It's not really odd. If you know that A is larger than B and B is larger than C, what does that mean? A is larger than C. That's the same idea. It's called transitivity. Okay? Okay. Just some notation for us to define. Yeah. Go iPad. So here we got C extends B, B extends A. So implicitly, C also extends A, implicitly. In some way, we can see that C is a descendant class of A. Okay? Yeah. Also, go back to our binary tree terminology, descendants versus ancestor. Okay? Okay, let's go back there. Now, ancestor versus descendant. So hopefully I don't have to spend too much time on this terminology since we learned that from the binary tree. Okay? So now what's ancestor, what's descendants? Okay? So now over here, ancestor class means the class itself, also its parents, and etc. up to the root. Okay, that's ancestor classes. Okay, now let me give you one example over here. So now let me just draw that over here. Let's say we have A over here, and then let's say we have B over here, and then we have C, and then we have D. It's a simple class hierarchy over here. For simplicity, let me say I also got attribute A, attribute B, attribute C, attribute D. Let's say we have that, okay? So now let's use this example here to illustrate the points that's mentioned in the slides. Let's go one by one. First of all, we say that A inherits all the code from its ancestor classes. What does that mean? Let me show that to you. Let's take this class, for example, over here. First of all, what are the ancestor classes for D? C and A, also itself, right? You can see over here, these are the ancestor classes of D. And when I say things like inherits all the code, including attributes and methods from its ancestor classes, so what does that mean? So now that means from D over here, not only that I got D available, I also got C, I also got A. Okay, I inherit all the code from my ancestor. Okay, that's what this point is saying. Okay, so now what does that mean? Again, let's try to go a little bit further. Since in the lower the class is in the hierarchy, the more code it is going to accumulate from its ancestor classes. That means if I talk about expectation, again, if I go back to this diagram over here, these are the expectations on D. Okay, what are the expectations for C? A and C, right? Okay, so we got also A and C. So these are the expectation for on C. In this case, you can see that D is a subclass of C, and we have wider range of expectation simply because we define new attributes or new methods over there in the subclass in general. Okay, hopefully you're still okay. Okay, now similarly, we also define descending classes in the other direction. Okay, so the descending classes is going to inherit all the code from its ancestor classes. Okay, now again, the most important thing for you to remember is when we talk about ancestor and descendants, whenever you talk about a particular class over here, it has wider range of expectations than its ancestor because it simply is going to define new attributes or new methods. So you can expect more from that. You can expect at least as many, okay, compared with its ancestor, okay, at least as many. Okay, let me just write it down explicitly and then I'll move on. So now if you compare these two, we can expect at least as many on D compared with C. At least as many, okay? Now let's just go over one more slide and then we'll present some rules for you, okay? Now, again, I'm going to repeat the point again just to make sure you understand. So inheritance, first of all, is really about code accumulation. Whenever we define a new subclass, we're accumulating more code from the ancestor classes, okay? The lower a class is, the more code it accumulates from its ancestor, okay? We just illustrated that. And also, in the descending class inherits all the code from ancestor classes, okay? And also, descending class, what can we do in the descending class? We can also define new attributes. That's why we got wider range of expectation. Also, we can define new methods. We can redefine or override existing methods, okay? Now, what's the consequence? Okay, the consequence is really important. The consequence is when we are expecting, for example, over here, we can have wider range of expected usages. So now if we have over here, if I say C, object C, and D, object D, we know that we can expect more from object D, right? Because D over here has the expectation D, C, and A. But for object C over here, the static type is actually C. And what can we expect from that? We can only expect A and C, right? Only A and C. So you can see we can have wider range of expectation in the descending classes, okay? You might be still wondering, why are we learning this? You will see it's actually very important for you to judge whether something will compile or not. It's really important. Okay? So now, that means whenever we are expecting an object of a particular class, we may substitute it with an object of its descendant classes. Okay? Let's now go back to our original example over here. Okay? Let's now see that. Let me just go back to iPad, maybe. So now let's go back to our original example over here. When we try to compare these two assignments over here, right? We say either should this compile or should this compile, right? Okay. So now you can think of why line number 1 should compile, because think about this. Okay. Let me just go again. No, let me just write it down. Okay. Again, we got students. S is assigned to something over here. Also, we have resident students. RS is also assigned to something else. Okay, now, why does S is assigned to RS compile? It compiles, first of all. Okay, so now you can see that, first of all, let's look at the static type. So this is the static type for S. This is the static type for RS. Okay, and we know that this one over here, resident students, has wider expectation than students. Well, in particular, premium rates. I'll say PR, premium rates. That is why now I can say now I'm expecting some students over here S. Okay, I can simply substitute it by something that is descendant class. Okay, so now if you look at the static type of S is students. And then you can see that the static type of RS is resident students. How do we decide whether this line should compile? One way to do it is proof by contradiction. But you don't have to do proof by contradiction always. That'll be too time consuming. This is how you judge. This is the rule. If I say I want to assign something into something else, this is how you judge. First of all, we know that this is the hierarchy over here. Students, and then we have resident students, and also we got non-resident students. We simply ask the following. Is the static type on the right-hand side, which is resident students, is that a descendant class of the static type on the left-hand side? In which case, we're asking if is resident students a descendant class of students? In this case, yes. So that's why this will compile. On the other hand, if we write something like this, RS is assigned to S. In that case, we are really asking, is the static type of S, which is students, is students a descendant class of RS? No. That's why it doesn't compile. Okay, that's a rule, which I'll present more formally. Yes? You know what, if you want to ask about super, right? So I would say it's not really relevant to what I'm discussing right now. So how about after class? Okay, yeah, good. Okay, let's, guys, any question about this before I move on? Yes? Say that again. So what do you want to do? Okay, I see what you mean. The question was, what if, so let's say we still have, I see what you mean. Let's say we still have students and also resident student, okay? Let's say that, I see exactly what you're asking. So now let's say we still got name and also number of courses and courses, okay? And so we got these three attributes here, and also we got all the methods. Let's say in the resident student, we don't declare any new attributes, and there's no new methods either. Let's say, okay, it's basically the same object structure. Now your question is, if I now say students over here is something, and resident students RS is this. Now, would it work if I say RS is assigned to S? Okay, the answer is No. No. The answer is no. I tell you why. Maybe it is the case that at the moment, the two classes look just the same. But maybe in the future, you might decide they want to add more attributes in the resident students, in which case the compiler have no control over. As soon as you do that, whatever they used to compile wouldn't compile anymore. Okay, that's why. Okay, so here you can see the rule we are trying to really learn is really the rationale behind how they implement a compiler in Eclipse for Java. So the compiler is not, in some ways, not very flexible. It wouldn't know anything about whether the attributes between the two classes are really the same. It only knows that RS extends students. That's all the compiler knows. So it doesn't matter if the attributes are really the same. Doesn't matter. So this will still not compile. Okay. Okay, let's go on. Okay, so now you can just read it over. Okay, now let me just define again static type. Keep mentioning about static type. Let's just talk about it very quickly, and then we'll talk about substitution. So now we talk about static type for any reference or object variable. But what do we mean? What do we mean by that? So when I declare Jim to be a student, this type over here, student, is a static type. Okay, I'm going to use a convention here. Whenever you see green for the class, that means it's static. Whenever you see red, that means dynamic. Okay, so now that means we declare the static type of Jim to be students. Similarly, if I say, oh, let me just explain very quickly another class hierarchy here. Okay, you can also download the diagram from the website. Okay, let me just explain that very quickly, which I'm going to use. Let's say we just got another inheritance hierarchy here for smartphone. So let me go over very quickly. So let's say on the top we got smartphone. Okay, under smartphone it might be either iOS or it can be Android. Either way, under Android it can be iPhone 6s or iPhone 6s Plus. Okay, and under Android it can be either Samsung or HTC. And under Samsung it can be either of these two brands, or for HTC it can be either of these two brands. Okay, that's a simple hierarchy. Okay, may not be realistic, but hopefully that will illustrate the idea. Okay, now what about the methods? So now at the top over there, we are trying to define the most common methods for all the smartphones, in which case we define dial and surf web. So what does that mean? That means for every smartphone, there are two things we can expect, either to dial or to surf the web. So these are the basic functions. Okay? Now, in iOS, we might override or redefine the surf web. Maybe we say that whenever you want to surf the web, by default, it's going to be Safari. Okay? On the other hand, for Android phone, we also are going to override the surf web method, which means maybe by default, it's going to use Firefox, okay, for example. And then in the iOS, we also define a new method over there, maybe FaceTime, which is not really available in Android. For Android, we also got, by default, maybe Skype. Okay? Just I kind of make it up. And then, well, it might be true, but not really completely make it up. So now in iPhone 6s Plus, we also got something that's unique, let's say 3D touch. Okay? And also for the particular Samsung brand, it's called Galaxy S6 Edge Plus. They got some new, unique feature called Site Sync for syncing the files, I think. I just Googled that. Okay, you can do that too. Okay, just let's live with, without worrying about whether this is realistic. Don't argue me with that. I'm pretty sure it's not realistic, but just for illustration. Okay? Okay, now let's go back and see more example. Now, if I declare my phone to be smartphone, that means at the runtime, my phone can be what? Can be iPhone, or can be Samsung, or can be HTC, okay? Dynamic type. Now, the static type never changes, never ever changes. That's why it's static. And because it never changes, this is the only information the compiler is going to use in order to decide if your code compiles or not. The code cannot keep track of the dynamic type of your program. That's what I will show you. Okay, and now what's really important about a static type is it's about defining the expectation on the variable. If I define Jim to be students, that means the only methods I can call on Jim or attributes will be name, courses, number of courses, register, or get tuition. I cannot say Jim.premium rates, for example, right? Because that's only specific to resident students. Okay. Similarly, I cannot say myphone.3D touch. I can only say myphone.dial or my phone does surf web. These are the only two things I can expect from a smartphone. Okay? And then, so that's the expected usages. Okay? So now, if we declare, like exactly what I said, if you say student Jin, we can call register with get tuition method, but we cannot call set premium rates, okay? Because it's simply not defined on the static type. And then, if we say my phone, smartphone, then we can only say dial or surf web, but we cannot say FaceTime, for example, because FaceTime is specific to iOS. Guys, any question about static type? Two things you should know about static type. First of all, it never changes. Second, it defines the expectation on the variable. Okay, so these are the two things. Dynamic type is more sophisticated, but it's not too bad. Okay, now this the next two slides I will go over them quickly because the idea in some ways not conceptually it's not too difficult, but if you want to put it formally, it's kind of dry to go over. So I'll leave you to read them, most of them. But I just want to give you some idea. So let's say we declare in general. If we declare a variable called v1 of type c1, you can see c1 is a static type of v1. Okay, one variable. We got another variable. When we say v2 of static type c2, just in general. Okay, c2 and c1 or v1 and v2 can be anything. Now, when we say v1 is assigned to v2, what do we mean? Okay, what we are really trying to say is a diagram like this. So now you can see v1 used to point to some objects over here of any type. The type doesn't really matter. Used to point to something. And now v1 is going to point to wherever v2 is pointing to. So that's why the arrow is changing over here. So now we call such assignment a substitution. Okay? So now, when can you do such substitution? It's subject to some rules. The rule is the static type for v2 must be a descendant class of the static type of v1. Okay, that's something we have gone over in the examples. I just want to put it a little more formal for you over here. Okay, I'll leave that to you. And now, what's the rule for substitution? Okay, this is the number one thing you should know. For you to be, so somehow you don't want to rely too much on the compiler because if you rely on too much, you have to keep fixing the compile time error. You rather know what the rules are yourself. So this is number one. This is basically the one of the very few rules you have to know. If you are expecting an object of static type A, if you declare something to be of static type A, what can you assign to it? The only thing you can assign to it would be any objects whose static type is descendant. It's actually a descendant class of A. Okay, give you one example. Okay, example here. Let's say over here, if you're expecting an iOS phone. Okay, let me just write it down. Let's see this hierarchy over here. If I say iOS my phone, let's say I'm very picky. I only accept iOS phone. In this case, what can you give to me? What can you substitute for me? In this case, well, you can only give me either iPhone 6s or iPhone 6s Plus, because these two classes are the descendant classes of iOS. So that's a rule. You cannot give to me, for example, Galaxy, even though it's good. Doesn't matter, because I'm expecting iOS. If you give me something that's not a descendant class of what I'm expecting, that's not good. It's not going to compile. Okay, that's kind of intuition. Again, every time you want to determine if something will compile, look at the inheritance hierarchy and look at the static type. Okay. Okay, I'll leave the rest to you. That's actually the other way. You have to say what would not be safe to do. Okay, similar. Okay, guys, any question about static type before I move on to dynamic types? Are we okay? Okay. Now, dynamic types is slightly more complicated because as opposed to static type, which never changes, dynamic type can change anytime you like. Okay? Let's see. Now, a reference variable's dynamic type is the type of object that is currently pointing to at the runtime. Okay? Now, so how can you change the dynamic type? Every time when you do assignments to a variable, some reference variable, you're changing its dynamic type. Okay? Let's see how in just a moment. And there are two ways you can change the dynamic type. There are two ways. I'll show you both. And now, let's see how you can visualize static type versus dynamic type. That's also important when you draw the diagram. Let's say this. If I declare student S, S to be of type students, in this case, student is a static type. Now, if I say S is assigned to new resident students, in this case, S is now pointing to a resident student's objects. Okay? Now, in this case, we say that the student is the static type. And then resident students over here is the dynamic type. Are we okay for this? Now, we can just, basically, you can see the box over here is an object. You can just read the terminology over here. I'm just showing it to you, how you can read it. Now, so what does it really mean when a dynamic type changes? That means if you just got another box over there at the runtime, and then you simply change the arrow to point to something else, in that case, you're changing the dynamic type. But the static type for this variable here never changes. Okay, it's only the box that's going to change. Okay, now, there are two ways to change the dynamic type. Okay, I'll show you both. The first way is very easy. Whenever you use a new keyword, that's changing the dynamic type. Okay, so now, let me give you one example here. When I say Jim is assigned to a new resident student's objects, in this case, what do I mean? I mean, after executing this assignment here, the dynamic type of Jim is going to become resident students, right? It's going to point to a resident student's objects, okay? And then, if I try to do this one here, and I say, yeah, how about this? I'll just use iPad to show you. Again, let me say this. Students, S is new. Resident students, okay, something over here. First of all, does this line compile? How do we judge? First of all, we know that this RS over here is the new dynamic type. The new dynamic type of S. How do we know if this line compiles or not? We simply want to see if RS over here is a descending class of students. In this case, yes. So this line compiles, okay? What happens after this line? That means now S is now going to point to a RS objects over here. So that's a dynamic type, okay? Let's do another line. If I do another line over here, I say S is now reassigned to something else. I say that's assigned to new non-resident students. In this case, what do I do over here? That means I'm creating a new non-resident students objects. And then S, rather than pointing to here, it is now going to point to here. Now, what's the new dynamic type for S? Non-resident students, right? So now, let me just say it again in different color. In the red, in the original step, dynamic type of S is resident students. Now, on the blue over here, dynamic type of the same variable here is non-resident students. But what about the static type in both cases? Students, static type never changes, okay? Don't forget. Okay, that's the first way of doing it. Okay, what's the second way of changing the dynamic type? You know, the first way, in some ways, very easy to keep track of for yourself, because whenever you see the new keyword over there, you can simply see that's a new dynamic type, okay? But now, in the second way, it's slightly more complicated, slightly. You have to draw some diagram to keep track of that, okay? Let's see this. Again, let me just draw the diagram again. Go back to iPad here. Let me just use, again, our example there. Students, let me say line number 1. S is new students. Number 2. I'll say RS just to save some writing. Resident students, RS is new. Resident students. Okay. I want to make it a little bit more interesting for you. So what about I change this to be students, which it also compiles. Okay, third line. I say students over here, NRS is assigned to new non-resident students. Okay, now number 4. I say S is assigned to RS. Number 5, I say S is assigned to NRS. Okay, first of all, is there any line that does not compile? Nope, nope, right? Everything compiles. Okay, good. Now, very quick review. Why does line number 4 compile? Why does that compile? Okay, whenever I ask you the question, does the line compile? Look at the static type only. What's the static type for RS? Static type. Students. The static type is students. Be careful. What's the static type for S? Also students. Now, the question you should ask is students over here a descendant class of students? Yes, so it compiles. The same reason for 5. Okay. Now, I'm going to draw a table over here. Okay. Okay. So now 1, 2, 3, 4, and 5. Okay. And then I'll say static type of S. Dynamic type of S. I want you to tell me for each entry in the table. So when I say 1 over here, I mean after executing 1. After executing 1, after executing 2, 3, 4, and 5, etc. Tell me what the static type should be for S and what the dynamic type should be for S as well. Let's try 1. After executing line number 1, what's the static type for S? Students. Dynamic type? Students as well. Very good. Because you can see that we actually got this new keyword here, right? So that means it will be students. What about line number 2? After executing line number 2, what will be the static type for S? Students, never changes. Now, what about dynamic type? Be careful, I'm talking about S, not RS. Student as well, right? Because I didn't reassign that. All right, be careful. That's also students. Now, hopefully you can answer the next one. What about line number 3? After executing it, student, right? Again, static type, don't even think about it. It's going to be students throughout, never changes. After line number 3, we haven't really reassigned yet. Okay, so that's also students. Now, when you go to line number 4, after executing it, what does that do? Resident student, right? Okay, let me just show you this one very quickly. Because S is now pointing to some student objects over here, and then RS is pointing to some resident student objects. Okay, and then when we say line number 3 over here, we are saying, not line number 3, line number 4. Line number 4 over here, S is now going to point to this object over here. That means that the dynamic type has changed from student into resident students, right? That's why over here that should be RS. What about after executing line number 5? What will be the dynamic type for S? Non-resident student, right? Because basically what's going to be the new dynamic type depends on what's the dynamic type of the right-hand side. Because you can see in line number 4, we are trying to assign S into something whose dynamic type is RS. So it's going to become the same, right? Because of aliasing. Okay. Similarly, it's going to be NRS. Okay, it's not too bad, but I would say in approach number 2, whenever you change the dynamic type of a variable by using reassignments, you just have to keep track of how things go. So that's why drawing a diagram will really help. Okay. Good. Okay, you can just go over the rest. Okay, now let's define polymorphism and dynamic binding. So these are really the terms you should really know if you learn about object-oriented programming. Okay. Now let's see that. First of all, what's polymorphism? That simply means an object variable may have multiple possible shapes. When I say shapes, the polymorphism, poly means multiple. morphism means like a shape, right? I believe that comes from Latin. So when you say an object may have different shapes, that means they may have different dynamic types at the runtime. Okay? So now, that means, let's say the students. Let's say we declare over here again, if I declare S over here to be of static type students, polymorphism means the dynamic type of the student S can either be a student, can be a resident student, or can be a non-resident student. Okay? So what does that mean? That means if I'm trying to call the same method get tuition, I may call different versions of the get tuition depending on what the dynamic type is at the moment, right? So now, in the case where I say over here, after line number 1, if I say s.get tuition, versus after line number 4, if I say s.get tuition, versus after line number 5, I say s.get tuition, it's going to actually call different versions of get tuition for me, right? Because after line number 1, because dynamic type is actually students, it's going to call the version that calculates the base amount. After line number 4, if I say s.get tuition, it's going to call the version that's defined in the resident students, which applies the premium rates. And similarly for line number 5. Okay? So that's the polymorphism and dynamic binding, they work together pretty well, closely. Okay? Okay, again, that's what I just said. And dynamic binding basically just go a little bit further from polymorphism. Since we know that the dynamic type of one object can change from one to another at a runtime, so that means the version of the same method you might call also change from one version to another at a runtime as well. So that's dynamic binding. Dynamic simply means it depends on what the dynamic type is. That's why it's called dynamic binding. Okay, you can just go, again, just a get tuition example. Okay, any questions until now? We're okay, right? Okay. Okay. Now, so there will be more examples about basically just exactly what I said up to now, just about how you can use the class hierarchy there, and then you can test the output. So these, we have talked about them already, okay? So I'll leave them to you, and then we'll get onto the next topic, okay? You can just go over them. Okay, also just another example with respect to this class hierarchy here. So what's expected for you to know by the end of the course? If I give you some class inheritance hierarchy, and I give you some fragment of Java code, you should be able to tell me if that line should compile or not, and why. Okay, that's something I would expect from you. That's really important, I think. Okay, let's now talk about why we need typecasting, which will go back to your original question. Okay, let's see this. Let's go over this carefully. Okay, let's say we got students, Jim is assigned to new resident students. First of all, this line, does it compile? Why? It compiles, I agree, but why? Exactly, very good. Because resident students on the right-hand side, the new dynamic type is a descendant class of student class. Okay, very good, very good. And let's say we declare another variable over here, and then the static type for RS is resident students. And then I do this line here. Does this compile or not? Why not? Exactly, so exactly. Because the static type on the right-hand side, Jin, is students, which is not a descendant class of the static type of the left-hand side of RS, which is resident students. Okay, that's why. But now, you might be thinking that, so let's say this is what I intend to do. I want to say RS, the set premium rate is 1.5. Let's see what's really laid out over here. And then I will tell you why this is some limitation for computers. Okay, has something to do with 2001. Okay, if you want to draw any connection from 2001 to the rest of the CS courses, this might be the most relevant ones, actually. Okay, let's try. Okay, now let's just draw the diagram very quickly. So here we say students Jin is pointing to a resident students objects, where we do know that we have a premium rate over here, something over here. Okay, that's the first line. And then we got another variable rs from line number 2. So we have rs over here, which is resident students. Okay? And now we try to do rs is assigned to Jim. We try to do this one over here. We try to. However, this is forbidden by the compiler. Let's say what we intend to do is something like this. We intend to say rs the set premium rate to be 1.5. We intend to do the following. rs dot set premium rates to be 1.5. This is kind of what we intend to do. However, the compiler, in some way the compiler is not smart enough. Intuitively, we should allow this to happen, right? Because somehow you can see that the object that's being pointed to by Jim is really a resident student, which does have the premium rates defined, right? It does. In which case, we should really allow that, right? Because we can say rs as set premium rate, we can simply go to this object here and then do it, okay? Now, this is something to do with, I'll just mention very briefly, okay? Something to do with undecidability. Okay, we say that a problem is undecidable if you simply just cannot write any computer programs to solve it. Be it a computer program, maybe C program, Java program, or C++ program. So now, here is something that's undecidable in CS. Given any Java program, if I want you to figure out what's the dynamic type of a particular variable, in general, this is undecidable. Okay? Let me give you a project. If you can get this done by the end of the semester, I'll give you A+. Immediately. This is the problem. The reason I said this was because it's simply undecidable, right? You just cannot do it. Let's say this is your program. I tell you what, if you can really do this, what you really deserve is not A+. You deserve a Nobel Prize. Okay, let me tell you what the problem is. Let's say your program over here, you can write this program in whatever language you like, C++ or whatever, or Java. Your program is going to take 2 inputs. First of all, it's going to take something like a Java program. For example, let's say input.java. And then it's going to take the name of a variable, for example, s. Your output is going to be just one single thing. Tell me what's the last dynamic type of s in input.java. So here, when I say input.java, I mean any arbitrary Java program. This is a typical undecidable problem in computer science, which means there's no way for you to have a program like this. For example, I can give you one counterexample right away. What if the input.java looks like this? That looks like this. If I simply give you something like this, let's say students s is assigned to null. And then let's say eventually I would say s is assigned to new resident students. You might be thinking, oh, the last dynamic type should be resident student, right? But what if I put something like this in the middle? While true. In this case, what will be the last dynamic type of S? Can you know in general? Well, this is just one example I give to you. Your program must be smart enough to tell every case like this, in which case you simply cannot tell what's the last dynamic type for S. Again, this is an undecidable problem. Okay? Now, the point is, I want to show you that the compiler for any programming language is very limited in the sense that the only information they can get will be the static type. So that means in the situation like this, even though I know that Jim is really pointing to some RS type object, even if I know that, but the compiler wouldn't allow that. Simply, it's not flexible enough. Okay, do we have time? Okay, let me just stop here, and then we'll continue from Thursday. Okay.